Download this code from codegive.com, link in the description below. Creating creative base designs with code, a detailed tutorial. This tutorial will guide you through the process of designing creative and functional bases using code. We'll cover the fundamental concepts, explore various design patterns, and provide code examples in a pseudo-code format that can be adapted to your specific game engine or framework. Understanding the foundation, the base class. At the core of any code-based base design is a base class, or a similar concept, that encapsulates all the properties and behaviors of a base. This class will serve as the blueprint for creating different base layouts and functionalities. Key attributes of the base class asterisk. Asterisk location, position a vector, x, y, z in 3D, or x, y in 2D, representing the center or a designated corner of the base. This determines its placement in the game world. Asterisk size, dimensions defines the physical extent of the base. This could be represented by a radius, for circular bases, width, and height, for rectangular bases, or a bounding box for more complex shapes. Asterisk structure, layout, a representation of the base's internal organization. This is crucial for creative designs and can be implemented in several ways, which we'll explore later. Examples include asterisk a grid of tiles, for grid-based games. Asterisk a graph of interconnected rooms. Asterisk a list of placed buildings or structures. Asterisk resources, asterisk a dictionary or data structure holding the resources available to the base, example minerals, energy, population. Asterisk defenses, asterisk a list or data structure containing defensive structures, example turrets, walls, shields, and their configurations. Asterisk production, asterisk a list or data structure containing production buildings and their current activities, example factories producing units, research labs researching technologies. Asterisk utilities, asterisk functions for managing the base, such as asterisk add underscore structure, structure underscore type, position, adds a new structure to the base at a specified position. Asterisk remove underscore structure, structure, removes a structure from the base. Asterisk get underscore resource, resource underscore type, returns the amount of a specific resource. Asterisk consume underscore resource, resource underscore type, amount, reduces the amount of a specific resource. Asterisk defend, attacker, handles the base's defensive response to an attack. Asterisk is underscore within underscore bounds, position, checks if a given position is within the base's boundaries. Pseudocode example of the base class asterisk. 2. Structure representation, the key to creative design. The most important factor in creating interesting base designs is how you represent the structure of the base internally. This determines the flexibility and control you have over the layout. Here are a few common approaches. 1. Grid-based, tile-based. Asterisk concept, asterisk divide the base area into a grid of tiles. Each tile can hold a structure or be empty. This is common in RTS games and tower defense games. Asterisk implementation, asterisk use a 2D array, or 3D in some cases, to represent the grid. Each element in the array stores information about the tile, example what structure is on it, if it's walkable, its defense rating. Asterisk advantages, asterisk simple to implement, easy to check adjacency and path finding. Asterisk disadvantages, asterisk can be restrictive in terms of structure placement and shape. Requires structures to conform to the grid. Pseudocode example, grid-based. 2. Graph-based, room-based. Asterisk concept, asterisk represent the base as a graph where nodes are rooms, or key locations, and edges are connections, hallways, doors, between them. This allows for more flexible and organic layouts. Asterisk implementation asterisk use a graph data structure, dictionaries, adjacency lists, or dedicated graph libraries. Each node can store information about the room, size, function, connected structures. Edges can store information about the connection, door type, cost to traverse. Asterisk advantages asterisk very flexible, allows for complex and interconnected designs, can model pathfinding and resource flow more realistically. Asterisk disadvantages asterisk more complex to implement, requires careful management of connections and spatial relationships. Pseudocode example, graph-based. 3 list-based, free placement. Asterisk concept asterisk simply maintain a list of all the structures within the base and their positions. This provides maximum flexibility but requires more complex collision detection and spatial reasoning. Asterisk implementation asterisk use a list or array to store the structures and their associated data, type, position, orientation. Asterisk advantages asterisk very flexible in terms of structure placement and shape. Allows for organic and non-grid aligned designs. Asterisk disadvantages asterisk requires robust collision detection to prevent structures from overlapping. Pathfinding and adjacency calculations become more complex. Can become less performant with a large number of structures. Pseudocode example, list-based. 3. Design patterns and techniques for creative bases. Once you have a solid foundation with your base class and a suitable structure representation, you can start implementing creative design patterns. Here are some ideas. 1. Procedural generation asterisk. Asterisk concept asterisk use algorithms to automatically generate the layout of the base. This can create unique and unpredictable designs each time. Asterisk techniques asterisk. Asterisk random placement asterisk randomly place structures within the base boundaries, subject to constraints, example minimum distance between structures, required structure types. Asterisk cellular automata asterisk use cellular automata to create organic and interconnected layouts, especially useful for graph-based representations. Start with a random seed and evolve the base layout over time. Asterisk L systems asterisk use L systems, string-based rewriting systems, to generate complex patterns and branching structures. This is useful for creating tree-like or fractal-like base layouts. Asterisk Voronoi diagrams asterisk divide the base area into Voronoi cells, each centered on a specific point. Use these cells to define room layouts or strategic areas. Asterisk dungeon generation algorithms asterisk adapt dungeon generation algorithms, example binary space partitioning, random walk, to create bases with interconnected rooms and corridors. Asterisk example, random placement. 2. Symmetry and patterns asterisk. Asterisk concept asterisk use symmetry and geometric patterns to create visually appealing and strategically balanced bases. Asterisk techniques asterisk. Asterisk radial symmetry asterisk arrange structures around a central point, example a command center. This can create a strong focal point and provide equal coverage in all directions. Asterisk bilateral symmetry asterisk mirror the base layout across a central axis. This creates a sense of balance and order. Asterisk tessellation asterisk use repeating geometric shapes, example hexagons, triangles, to tile the base area. This can create visually interesting and structurally sound layouts. Asterisk golden ratio asterisk incorporate the golden ratio, approximately 1.618, into the base's dimensions and structure placement to create aesthetically pleasing proportions. Asterisk example, radial symmetry. 3. Functional zoning asterisk. Asterisk concept asterisk divide the base into distinct zones based on function, example defensive zone, production zone, residential zone, research zone. This helps to organize the base and optimize resource flow and defense. Asterisk techniques asterisk. Asterisk defensive perimeter asterisk create a fortified outer layer of defenses to protect the core of the base. Asterisk production cluster asterisk group production buildings together to streamline resource processing and unit creation. Asterisk research core asterisk locate research labs in a central, secure area. Asterisk resource management zones asterisk place resource gathering buildings near resource nodes. Asterisk example, functional zoning, simplified. For adaptive design asterisk. Asterisk concept asterisk design the base to adapt to the environment or the opponent's strategy. Asterisk techniques asterisk. Asterisk terrain awareness asterisk analyze the surrounding terrain and adjust the base layout to take advantage of natural defenses, example building on high ground, using cliffs as walls. Asterisk enemy response asterisk monitor the opponent's attacks and adapt the base's defenses accordingly, example building more turrets in the direction of the enemy attacks. Asterisk resource optimization asterisk adjust the production of resources based on current needs, example prioritize energy production if energy reserves are low. Asterisk implementation, conceptual this generally involves monitoring game events and adjusting the base's structure dynamically using the add_structure and remove_structure functions. It also requires a game engine that allows for runtime modification of the game world. 5. Thematic design asterisk. Asterisk concept asterisk design the base to reflect a particular theme or aesthetic. This can significantly enhance the visual appeal and immersion. Asterisk techniques asterisk. Asterisk architectural style asterisk adopt a specific architectural style, example medieval castle, futuristic space station, underwater city. Asterisk color palette asterisk use a consistent color palette to create a cohesive look. Asterisk material selection asterisk choose materials that match the theme, example stone for a castle, metal for a space station. Asterisk symbolism asterisk incorporate symbolic elements into the design, example a central tower representing power, gardens representing harmony. 6. Exploiting weaknesses in game AI asterisk. Asterisk concept, in single-player scenarios, analyze the AI's behavior and create base designs that take advantage of their limitations. This involves a lot of trial and error. Asterisk techniques asterisk. Asterisk choke points, force the AI to funnel their units through narrow passages, making them easier to defend. Asterisk decoy structures, build inexpensive structures in vulnerable locations to draw AI attacks away from more valuable assets. Asterisk resource traps, surround resource nodes with defenses to punish the AI for attempting to gather them. 4. Implementing the base in your game. This pseudocode needs to be translated into your specific game engine or framework. Here's a general outline. 1. Choose a game engine asterisk select a suitable game engine, Unity, Unreal Engine, Godot, etc., or framework. 2. Implement the base class asterisk translate the pseudocode into your chosen language, C, C++, GD script, etc., and integrate it into your game engine. 3. Create structure assets asterisk design and create 3D models or 2D sprites for the different structure types. 4. Integrate structure placement asterisk implement the structure placement logic, including collision detection, resource costs, and visual representation. 5. Handle game events asterisk connect the base to the game events, example resource gathering, enemy attacks, unit production, to trigger the appropriate actions. 6. User interface asterisk create a user interface that allows players to interact with the base, example build structures, manage resources, view defenses. 7. Testing and refinement. Thoroughly test your base design and refine the logic to ensure it is functional, balanced, and fun to play. Considerations for performance and scalability. Optimization. Optimize your code to ensure that the base logic runs efficiently, especially with a large number of structures. Data structures. Choose appropriate data structures for storing the base's state, example using dictionaries for fast resource lookups, spatial partitioning data structures for efficient collision detection. Multi-threading. Consider using multi-threading to offload computationally intensive tasks, example pathfinding, AI calculations, to separate threads. Object pooling. Use object pooling for frequently created and destroyed objects, example projectiles, effects, to reduce garbage collection overhead. Code profiling. Use profiling tools to identify performance bottlenecks and optimize your code accordingly. 6. Conclusion. Creating creative base designs with code requires a strong understanding of the underlying principles, a willingness to experiment with different design patterns, and a commitment to optimization and refinement. By carefully planning your base class, choosing a suitable structure representation, and implementing creative design techniques, you can create bases that are both functional and visually engaging. Remember to tailor these examples to your specific game and its requirements. Good luck.